Actually, for Kubernetes installation, we need three things to mandatorily. What is the type of installation we are going to be used? It is using the kubeadm. Using kubeadm tool, we are going to do the installation. And coming to the other thing, the container network interface. What is the container network interface and all? You might have discussed in the full description or explained in the theoretical part. So Calico, Flannel, there are a lot of CNI plugins are there. So in that I have taken the most popular Calico as CNI, container network interface. What it will do the network interface for the pods actually. And the other thing, the most important thing is to manage these Kubernetes applications by containerization. That containerization runtime engine we will use as a CRI-O. CRI-O. So CRI-O is my container runtime interface actually. So I'm not using the container D or Docker DR kind of things. There are other things to actually handle this Kubernetes CRI tool. But myself in this installation I'm using CRI-O, container runtime interface. So OCI based Kubernetes runtime. OCI is open container initiative actually, is developed by Open Container Initiative communities actually. Okay. Yeah. So actually what we are going to discuss and what are the steps is involved in the Kubernetes installation. This is the installation is managed by the kubeadm itself actually. There are a lot of other tools, a couple of tools are there to install the Kubernetes, but let's focus on this only. Kubernetes cluster setup using kubeadm. The scope of this installation is using kubeadm. I am going to be installing Kubernetes cluster. Why we are calling cluster? Because it's more than one node has to be installed to manage the clusters. Because one for master node and one for work node. Minimum 2 nodes required to install the Kubernetes cluster, and maximum it is better to have odd number of nodes. Okay, why odd number of nodes and all? You might have know that in the full details of the theoretical part actually. This is only the concentration on the installation part. Okay, let's discuss the step by step and then go get into the actual installation. Step 1 actually, the first of all we will provision the EC2 missions from the any cloud providers. EC2 missions or virtual missions from any of cloud. I have taken AWS EC2 missions actually. Two EC2 missions has been provided. I wanted to change the host name. Basically, EC2 cloud provided EC2 missions comes with the private IP address as the host name actually. So that I need to change first, and then it has to disable the swap space, because this swap space is usually the usage of the swap is to hold the least used data. It holds the least used data. So that is not good for the Kubernetes, because Kubernetes cluster is spontaneous and it is instantaneously, it has to be respond with the current states actually. Okay, so if you keep the data in the swap space, then it might be have some conflict, the current data and the already existing data. So that's what Kubernetes is not recommended to enable the swap space. And the third thing is to enable IP table bridges. These IP tables are IP table bridge topics are among the multiple nodes, cluster nodes, master and worker nodes. These are the has to talk each other actually. So there are some setups is there to enable this IP tables bridge actually. So step 4 to install container runtime. As we discussed, container runtime interface we are using CRI-O on CRI-O. This is holding the Kubernetes, holding the application containerization. So on top of it, everything is going on actually. This is again one of the core component. Okay. So step 5 is to install the Kubernetes admin tools actually. These are the three most important heart of the Kubernetes cluster actually. kubeadm is to manage the Kubernetes cluster. Kubelet and kubectl is the other important tools to handle the Kubernetes, handle the communication between the nodes, and kubectl is the tool which is the agent used to interact with the Kubernetes cluster. Step 6, initialize kubeadm init. What is this? This is the most important, and it is coming now onwards. We are going to be deal with the master node. Kubeadm init is the initialization of the master node actually. Kubeadm init can initialize the master node setup. Master node is nothing but a control plane. Okay, so this kubeadm join command used to join the worker nodes into the master nodes. This is the setup has been completed up to 7. But the network, why is required network interface means that network interface to communicate the pods actually. So what is pods and all you might have knows in the theoretical part. Then finally set up Kubernetes metric servers to measure, investigate the Kubernetes nodes, top CPUs, top resources using the memory, or pods which are using high CPUs and memory, that can be used to investigate, interrogate, and analyze the metrics of the server or nodes. I mean nodes, pods. Step 10 to just health check, deploy one of the Kubernetes pod and see the pod log files and describe that everything is configured as expected and or not. That is the health check. And finally, how to add worker node into the cluster. Currently, we are dealing with the 2-node installation, and 1 node we have to add to the existing cluster. It's very simple. As you kubeadm join in the step 7, how did you are joining the worker into the master node? The same step has to be repeat in the step 11 also, including everything has to install from 1 to 5, whatever is there, that has to be installed in the every worker node itself. Okay, so let's get into the main topic, installation. So this is my configuration actually, the explanation, high level steps. After that, these are the myself I'm going to be provisioning. Yeah, now I'm logging to the master server. This is my master server. I'm calling it as a controller, and this is my worker server actually. So the first step is to what has to do, change the host name. Okay, I'm changing the host name. Sudo hostname ctl set hostname kmaster.demo.com. Just myself, I am naming it as kmaster kubernetes master.demo.domain.com. .demo.com is your company domain name. .oracle.com, .linux.com, .kubernetes.io, kind of things. Okay, this is purely a demo purpose I'm using. Enter. So the affected host name has to be not showing here actually. It is still the private IP host name. So now let's execute this. So now you can see that it has been changed, kmaster. So now onwards my host name is kmaster. Okay, kmaster.demo.com. Clear the screen, go to the worker node. Let's execute same command here also. Hostname ctl set hostname kworker1.demo.com. okay, so I wanted to show you that before this one. Let me show you now what is my host name. This is my current host name actually. Let me change the host name now because I did not show you under controller. That's what I am showing here. Sudo hostname ctl set hostname kworker1.demo.com. Execute dash. Now hostname has changed. Let me check the hostname. See now the worker1.demo.com. okay, so what should I do after this? I have to add both of the nodes with both of the node and IP address in the etc file. So I have already taken the inputs. So this is my IP of the public IP, and this is my host name and the short name of the host name. I'm adding these entries in both the nodes actually. Sudo /etc host. Okay, sorry, sudo vi /etc host. Yeah, let me add it here. I have to add each and every node with every worker cluster node. Every cluster nodes entries. So all cluster node entries should be there in the all nodes. Sudo vi /etc hosts. Okay. Yeah, I'm saving it. Fine. Let me ping each and every node. Ping Okay, let me ping the master node from worker node. Kmaster. Yeah, able to ping now. Ping kmaster.demo.com. Able to ping. Yes. Now let me ping from the master to worker node. Ping k worker 1. Yeah, able to ping. Same demo.com. Yes, able to ping. Okay. Now the first step has been completed. What is that first step? Let me close this one. I don't require it. I'll cancel it. Let it be. What is the first node? Yeah, the step 1 is completed. Now I'm going to step 2, disable the swap. So I'm going to disable the swap. Sudo swap of hyphen yes show. Is there any swap on hyphen yes means show. So if anything is displayed here, then swap, it seems to be swap is on. If nothing is displayed, it means swap is already off, because EC2 missions comes with the, by default comes with swap off. Okay, so how to, if something is displayed, how to switch off the swap? Sudo swap off hyphen a. This is the command to switch off the swap. Okay, so let's execute the same commands on the worker node also. Let me clear the screen. Sudo swap on hyphen yes. Swap on hyphen yes. Yes means show the, if anything is there, it has to show. Okay, now it is not showing anything. It means it has swap off in this server also. Anyway, I am executing to off it. Swap off hyphen a. If you want to on, swap on hyphen a. Okay, the second point also completed. Swap. Disabled swap, by default it is disabled. Again, I have just executed how to disable the swap. Now the third step is IP table bridges. This is the first step has been completed, and the second step is disable swap. This also completed, and this one I have to copy paste it exactly. So what happened? Execute the following commands on all the nodes. I have to execute each and every command up to 5th step. Both the nodes has to execute all these commands. So enable IPv packet forwarding actually to both the nodes interaction. Here are picking some kernel parameters also. These are the kernel parameters. Let me execute this one. I have to execute at both the nodes. Let me clear this one. Execute it. Let me execute it in the worker node itself. Yes, done. Then after, restart the setup of the kernels. I have to execute it on both the nodes. Yeah, okay. Take this sysctl params required by setup params persistent across the reboots. Okay, execute this network kernel parameters. Execute on both the nodes, master and everything, until I tell you where to execute the command in only master and only worker. Until then, everything has to execute on the master server as well as all the worker nodes. One or more worker nodes are there. You should execute each and every command in every worker node. Okay, let's restart the kernels. Without restarting the server, we are restarting only the kernels. Yeah, it is affected. Okay, ignore this invalid argument. Done. Okay, clearing the screen. Yes. Okay, next, fourth step. Install container runtime on all the nodes. Container runtime, CRI, container runtime interface. It required to run the application images actually. Okay, so run this one. In myself actually I am using CRI-O. Why? Because all the CKA, CKAD examinations, they will use CRI-O. Container D, Docker engine, CRI Docker D. These are the other container runtime CRI tools are there. but CRI-O is the most preferred one, and and all the certification exams will be asked based on the CRI-O only. Okay. Now, what should we do is we have to update the server kernel parameter, server packages, all the packages in the server first, because servers should be up to date before going to install any software. Okay, because these are the fresh servers. In real time, you don't might be required. If already it is used one, you don't require to update the servers. So, but as per the instructions given in the Kubernetes installation, you have to do it on anywhere, either real time or demo, anywhere you have to follow the same thing. Okay, it is updating. Yeah, update is completed. Clear the screen. Clear the screen. Now I have ran the update. Server packages has been updated. Now what should I do? I have to install some of the software properties, common curl and apt transfer HTTPS and CA certificates. These are the packages has to be installed. These are the prerequisite before going to configure the cluster. Copy on control node. Copy paste. It is installing. Yeah, installation is completed. Now on worker node. Yeah, on worker node also installation completed. Now what is that? Add the CRI-O repository. So each and every software in Kubernetes, there should be a repository. Its own repository is there. So that repository has to be included in the server repository, so that the continuous updates, if anything we get from the CRI-O, then that will be updated in our CRI repository, in server CRI repository, so that it is better to be our softwares are up to date. Okay. Take this completely. It is standard. I am not writing anything here. It is comes from the kubernetes.io official documentation. Okay, let me clear the screen. Copy paste the whatever I have copied. Enter. Okay, permission. Sorry, sudo. I have to log into the root user. Enter. Yeah, completed. Worker node also. I am logging into the root user. You can install everything as a root user. I am using before that there is a sudo, that's what. Okay, so copy paste, enter. Install the packages. Again update now, because CRI repository has been updated. Now we have to update the servers again to sync up with our server packages inventory and the CRI inventory, package inventory. Now everything is up to date, up to here. Clear the screen. Clear the screen. Yeah, go and get the CRI-O, kubelet, kubeadm and kubectl packages. Copy. Okay, let me get it. Let me edit this one. Yeah, permission there, sudo. Okay, fine. Sudo. Sorry, let me clear this one. Okay, step 3 has been completed, and let's start with the step 4. In step 4, we are installing container runtime on all the nodes. As we discussed, CRI-O I am using as a container runtime interface instead of containerd or Docker engine CRI containerd. Because in most of the Kubernetes certifications, they use CRI-O as a the container runtime runtime engine, CRI engine actually. So that's what we are installing the CRI-O. For further practice also, it will be very useful for you. Okay, let's install the CRI-O. For that, we need to do some of the settings actually. So before that, we going to install the CRI-O. We have to update the softwares on all the nodes. I mean, I have only 2 nodes, so I'm updating. Yeah, I have to update the server software package repository. Yeah, completed, and install the required packages, applications to run the Kubernetes smoothly. This is not actually my assumptions, and these are all copied from the Kubernetes official website. This is the standard documentation. Some of those are here and there I have changed only. Now add the CRI repository, CRI-O repository, container runtime engine repository. If it is not there, you will not get the continuous updates actually from the um, CRI-O. So that's what you have. You must have the, okay. It requires sudo permission, root permission actually. Sudo -i. Now copy paste. It's complete without any issue. Yeah, completed. Exit. Go to the controller also. Do the same thing. Clear the screen. Sudo -i. Copy paste. Run it. Yeah, this is also completed. Now what is the next step? Restart the daemons, CRI-O daemons, because CRI-O has been installed. We need to restart the CRI-O. It is one of the application. It is running process. It is running in the cluster servers, so we need to restart it after installation. STL status CRI-O. CRI-O not found. Okay. Okay, let me install CRI tool. I have to install the CRI tool, then has to restart it. Let me run it as a sudo user. Now it is installing. The same copy paste to the worker node. Started installing. Yeah, it's completed here. Clearing the screen. It is also on worker node also going to complete. Yeah, completed and clearing the screen. Okay, CRI also installed and needs to enable it and reload the CRI after installation so that it can be properly running. Yeah, done. And also on worker node daemon run done and enable CRI on both the nodes. After restarting the servers itself, if you enable it, it automatically runs. Otherwise, you have to manually bring it up. Done. Let me start. Seems to be it is already running. Just the sake of purpose. Yeah. Let me check the status. Systemctl status CRI-O. It is running and also enabled after rebooting the server also it will run. So started container runtime interface for OCI CRI-O. Both the nodes shows the same thing. Sudo systemctl status CRI-O. Okay, got my point. So now the basic component runtime container runtime has been done. Now the next step is to install the kubeadm, kubelet and kubectl on all the nodes. Okay, for that here I am the purpose is I am installing 1.28 not 9, currently running 1.29 as of at the time of installing this at the time of this demo. So I'm using 1.28 because it required after upgrade. How to upgrade also we can test on this servers itself. So let's run this. First set up the Kubernetes version. If you are not specifying anything, it takes the current version, latest version, and it will run. It means 1.29 it will go to install. So whatever you have setting up here, you have to mandatorily you have to choose the same thing. Okay. So variable I am setting in the both the nodes. Let me clear the screen. Let me clear the screen. Both the nodes I have to set the variable environment variable Kubernetes underscore version so that at the time of installation of the Kubernetes, it pick up 1.28 only from the server repository. Now run this repository. Kubernetes repository has to add along with the CRI and server packages. Oh, sorry, I need to specify sudo. This must be run with the root user only. Sudo -i, run this one, add it in the repository. Now update the repository. Again, after installation, you have to update this. Update it. Updation completed. And get out into the root user, because I am using sudo. Most of the time sudo will be enough for that, not required to install everything with the root user. Okay, after Kubernetes repository updated with our server, then we have to update the server repository again, once again. Okay, let me clear the screen. Okay, because after the Kubernetes repository updated with server repository along with the CRI-O and all, we need to update one more time to sync up all these three repositories, so that there will be no conflict further. Then after, let's see the what is current set of versions are updated now, available versions, because we have already updated this 1.28, because currently running 1.29 at the time of giving this demo. But why I am using 1.28 means after some time, I mean after the next session or next session, I will do upgrade the Kubernetes cluster, so that I will show you the demo. It should be all 1.28 extensions. Oh, sorry. So in the both the nodes, these are the packages available, 1.28, 0.1. Now our one is we are going to install 1.28, 10. 1 is major version, 28 is minor version, 10 is patch set version, and 1.1 is the minor updates. So the next step is completed, because install the first one, we can practice cluster upgrade task later. Now install packages. What are the packages are required? Kubelet, kubeadm and kubectl. So if you are not specifying any version after the tool, it will pick up the latest available version, means this one. So what should I do? I am directly taking the latest version available in the server, this one, and then I am trying to install it. I have to install on both the servers. Completed. Clear the screen. And master node completed, and worker node I am going to install. Clear the screen. Try to install kubeadm, kubelet and kubectl. Kubeadm is the management tool which can be manage and destroy the Kubernetes cluster. Kubelet is the node agent. It can be interact with the Kubernetes cluster nodes. And kubectl is the tool which can be the interface to interact with the Kubernetes API server. This has been learned at the theory part actually. Okay, up to here it is completed. Let's go for the next page. Next page is nothing, just explained everything. These are the things. If you are not specifying any version, that will going to what happen. If you are specifying something version at the time of installation of the tool, that can be pick up the specified version and it will start installing. Now what we have to do, unexpectedly it should not go on upgrade. That's what we are holding, the marking it has a hold for the further upgrades on both the servers. So we should not get the surprisings at the time of installation or at the time of runtime of the applications. Okay, whenever we require, we can do the upgradations. So that's what we are putting these three components on hold. You should understand one thing here. I am just putting these three tools on hold. It means tomorrow if you are going to upgrade your cluster, these three tools only going to be upgrading. That means the cluster is going to be upgraded. So these three tools repose has to update with the latest version, and then you have to start upgradation. That we will discuss in the next tutorial. Okay, next session. Okay. Okay, let's go further. Now, this is the main topic, main step to going to be initiate the master node now. Initialize Kubernetes on master node to set up control plane. So, master node, control plane are both same. Technically, the server itself show that it is a control plane. In worker nodes, it shows that worker as usual. So, as usual, this is the replace with IP address of your master node. Private IP address has to be changed. So let me check my master node private IP. I am not touching any worker now. I am going to, this black color is my master node. Let me check what is my IP address actually, private IP address, because I provisioned this server EC2 server from the AWS. So I must having one of the IP address, IPA. So this is my IP address. How can you get the IP address? -I. This is public IP. This is my private IP. Okay, so this is what I am going to take it actually, and I am copy pasting here, changing this one with my private IP, not public IP, private IP. Don't put anything. And this is pod siders. If you want 10.1. Then you can take. This is up to your choice actually. It is better to go with the 192 series only. So this is all is network related, so you should be very careful and should be understand what is it actually /cider 16 and all. Okay, there is a lot of meaning actually. The pod cider is most important. If you misconfigure anything, then you cannot provision the much pods on the node. Okay, this is a big topic actually. Networking is big topic. How to manage these ciders and what is mean of it. How many pods can be provisioned in each node. Okay, so that is different topic. Let me enable these all configuration, variables I have set up. Now check this. My IP address is I have given master node IP address. Now I am going to run this one. This is to initiate the master node now. Everything, because all the variables have been set up here. IP address also here. Node name also, IP address, node name, pod cider, everything has given. This is optional actually, because we already disabled the swap. If you are not disabled the swap, it will throw the error, because to ignore that error, that's what this this variable is defined here. If you are not defined also, it is not good now, because we already disabled the swap space. Copy. I am not putting this in the this one the command line. See, carefully observe this. This is the very important steps it is going to be activating actually. Enter. See, initialized the Kubernetes version 1.28.0. This is the major version. 1 is the major, 28 is the minor, 10 is the patch set. Okay. Pre-flight mode. It will check the pre-flight mode. Everything in the server is whatever required this kubeadm to install the Kubernetes cluster, that all the permissions and locations, it will check up the everything, and it will try to download all the images, like kubeadm will download all the images required to see this required to run the, what are those images? Kubelet, controller manager, scheduler, etcd, all these images it will download from the official Kubernetes repository to the local machine and try to install everything. After this one, it will start the pods, because each component in Kubernetes itself a pod. Okay, so after completion this one is the most important. If you want to add one more master node, you should run this one. If you want to add the worker node, if you want to add the worker node, you should use this one, join. Okay, so now it is better to copy paste this complete one first of all, and open one file in the master node itself. I am opening as master, node name itself master, and a copy pasting here. It required further also, because this code is required. Token, the token is required to join worker node into the master node. So enter. So whatever it is saying that I have to execute it now itself in the master node. This is master configuration file. It will be very useful further throughout this Kubernetes cluster lifecycle. So it is basically creating the etc kubernetes admin.conf that has to be copied from there to your home directory. .kube is the hidden directory and in the name of config, because kubectl is the agent to interact with the API server. At the time of kubectl tasks, the kubectl will look into the kubectl will look for the config file in the home.kube directory. That's what we are copying it. Now set up user owner permissions. Now it is done. So this is not required. What is the next step? This is the next step. You have to copy paste this one and run it in the worker node. Before that, let's check the master node status. kubectl, okay, version, okay, that is my version 1.2810. Now let's check this pods kubectl get namespaces. Short word is namespaces ns, default, kube node lease, kube public, kube system. These are the 4 default namespaces available in the Kubernetes cluster at the first time installation. Now check kubectl get pods. No pod is available because by default if you execute this command, it will pick up the resources, pods running inside the default namespace. -a means all namespaces including kube node lease, public, system, everything, whatever the pods are running, that can be displayed here. See, nothing will running, only system, because this is the first time, the first installation completed just. So no namespace having their individual pods, only the system has installed core DNS, etcd, kube API server, controller, proxy, scheduler, everything. At the time of kube init, whenever you execute kube init, the kubeadm will pick up the Kubernetes related component images from the official Kubernetes repository into your local machine, and it will install that, because these are the system pods. We call it as a static pods. These all static pods are required to run the system properly. Anyone is going down, your system, your Kubernetes cluster will not run properly. Each one having their own representation. Okay, be careful before going to run joining worker node. All these has to be up and running. Otherwise, you should not go until you troubleshoot these components. These are the most components, plain master node components. So let's see what are the nodes are currently running in the master node. kubectl get nodes. Only control plane. That means master node is there. Okay. Now I am going to add the worker node into the master node. Okay. Let me take this join command. It is useful further also if you want to join more workers. Go there, copy paste. It required sudo permission actually. Sorry, it requires sudo permissions. I have to sudo it first and then copy paste it. Oh, sorry, not this one. This one, copy paste it. See, this also will start kubelet starting. Now see this, it will complete easily. Now you can see that what are the nodes are running in the master node now. kubectl get nodes. The node short form is NO. kubectl get nodes. See what happened? Ready. It should be ready. kworker1.demo.com control plane and worker node. Let's see this. Let me clear this. There is no use of it, the worker node further on it. So I am closing the worker node because we don't require and we don't run anything in the worker node. We just go ahead with the control plane only further any task. Okay, let me go with the next step. So what we have discussed after that, all we did all these steps to validate the health check of the cluster. This is the actually really it will display a good output actually, how the control plane and other nodes are working. These are the set of instructions, actually set of health check validations has been completed. So everything should be okay. So now this cluster info gives you the DNS and master node endpoints. This is the Kubernetes control plane endpoint, and that this is the core DNS endpoint. These endpoints are required to interact the core components with outside or inside. This we will get into the nodes in the theoretical part actually. It is not part of the discussion in the installation. Let's go into the other. See, this is also completed. Join the worker node into the master node. We have completed this one. After all this, we have to be understand one thing. Everything is completed, but when you create the pods, that pod has to be exposed to the other nodes actually. So how it will happen? Once you deploy everything in the master node itself take care, the components itself take care to spread across the other worker nodes. But the pods has to be interact each other, because of the pods running on the same node has to be interact with each other. For that we need CNI, container network interface. So we did not install the CNI. Now we are going to be installed now. So for the CNI, yeah, no, this is also not defined by me. This is the standard documentation coming from the Kubernetes official documentation. And Calico, Tiger Calico is the CNI plugin. So I'm going to install this one. This is most important. Where it is going to be installed actually, kube system namespace. Let me check once again the kube system namespaces. What are the pods are running? kubectl get pods f1 ia enter. So now this is core DNS and etcd API server and controller manager proxy and scheduler running. Let me run this Calico pod network plugin. Let it completed. Now check the what are the pods are running in the kubectl. You see that container creating. This container is creating Calico kube controller and node manager. These are the node spreads across. How you can see that? Let me show you again. Yeah, now it is in the running state but not yet ready. It's showing 0 by 0 means not yet ready. This time it should be ready. Yeah, now it is 1 by 1 means I have my requirement is 1 and desired is 1. Okay, so both are equal. If anything requirement and current requirement and desired one is different is there, it means some of the pod getting some issues. So you have to investigate using logs, kubectl logs and pod name, so that it will be how you can investigate kubectl logs pod name. Let's one example, not actually going to be much deeper into that investigation. This is only the installation. You can see the logs of pods only, not other things. So resource name is need not to be okay. Sorry, actually I have to mention the namespace also. Kube system, because the namespace by default it will pick up from the default namespace. So that's what it is throwing the error. You can see that without any issues the Calico has been brought up. See that if it is not bring up, you should be investigate like this way. And also there is a one more way to investigate. It is most important in the at the time of certification. Any pod is not getting actually up, then you should use two commands, kubectl logs or kubectl describe. These two commands will investigate the whole system in the all the pods, their running capacity, I mean running runtime errors and everything will be displayed, these two things. Okay, so in the troubleshoot section that we will discuss. So now CNI installed, the all pods are ready to be deployed. So the next step is to deploy one of the pod deployment, simple pod deployment, and then see the how this installation is going in actually. And one more thing is there, we have to install the we have to install this one metric server we discussed, right? Basically this is not part of the installation. I am showing it as a Metric server is the most important, and many of these systems having metric server as a different add-on applications are running, like Prometheus and Grafana. So that will use it to calculate the server capacities, spaces and all. I mean, memory, CPU usage, and a lot of things it will gather actually, logs, so trace and everything. But as of moment, just I am giving the brief about the what is metric servers, how metric server will run. Basically, once the Kubernetes is not brings with the metric server or CNI, that is the add-on plugins actually. So anyway, CNI we have been installed, and the metric server. So let me check the metric server. kubectl top pods. So metric API not available. Top pods means all the pods top usage of the resources has to show actually. So it is showing the error metric API not available. So let me install the metric API. This is also the standard documentation. This has to be copy from the standard official documentation and get it to be installed here. Let me install it. Yeah, it's completed. Just wait it. It should be installed in the kube system itself. kubectl get pods -a. You can see the metric server. Earlier you don't see this one. So all system related. Now see, it is in running state but not ready, one pod. If you actually fire this command top pods, it will display error actually. Nkube system. Why the pod is not ready, then you will not get the output, because the pod is getting actually ready one by one. It should be shown now one by one. You can see now. At the time of 0 by 1, I mean desired and current state of the running pods, then the output should be like this only. API server not available. API metric API is not available. Okay. See this top pods. At the same time, kubectl get nodes. These are the two nodes I have in my Kubernetes system, because I have two node installation. kubectl top nodes. Now you can see that each node is consuming how much memory and how much CPU percentage. You will get it like this way. So before the plugin is not installed, you cannot execute these commands. It says that metric API is not available. Okay. So now that the API server also installed, this is all about we have installed CRI-O as a container runtime interface, and the CNI Calico is the CNI container network interface, and the container runtime interface and metric interfaces. These are the things has been plugins has installed, along with the kubeadm is the administrative tools. It is manage and destroy the Kubernetes cluster, and kubelet is the node manage agent. Between the nodes, it will be interact with each other to check the node availabilities, loads, and everything. It will contact with the master node. And kubectl is the tool that can be interact with the Kubernetes cluster. So these are all installation tools. And furthermore, I have to be explain you how the installation has been completed actually. How kubeadm is working actually. What happened in the free flight checkup? In the free flight checkup, it checks the registry.kubeadm.io. As I said in the installation, it will pick up all the images it required. What are the images? etcd, API server, controller, and controller manager, and kube proxy, and all these are it's like a small bits and pieces of softwares which is already provisioned in the Kubernetes official site, registry.kubeadm.io. So whenever you run kubeadm init in pre-flight mode, whenever started, it goes to the registry and pick up all these images into your local machine, and it will start installing this. We call all these pods as a static pods. It should be depends on the node name instead of the individual pod IP addresses. Okay, that I will show you in the practical and theory example of the Kubernetes cluster explanation in detail in other session actually. Then after it start TLS, transport layers, security, it is required, because Kubernetes is a much more dangerous application to hack easily. So that's what each and every layer and every step there is a TLS and the certificates has to be strongly deployed on every interaction with the Kube API server and contact between each of the components. Okay, so these are all certificates and TLS transport layer security certificates have been installed for all the components, static components in the HCD Kubernetes PKI folder. And in Kubernetes, each and every deployment, every application, even API server is one of the pod. A pod is nothing but an application. That application also has been deployed in the form of YAML file, right? So all the YAML files has been completely installed. I mean, YAML file is nothing but a manifest files. Okay, that manifest files are provisioned for these core components in the etc Kubernetes manifests. Got my point, right? So the fifth point saying that control plane components we started, we call it is a static pod manifest. Core DNS kube components, these are the kube proxy. Kube proxy is nothing but the proxy which is interact with the network of the nodes. Node bootstrap token. As I told you that I showing, we used actually joining at the time of joining the, let me show you one of the code actually, get master. I have shared it in that. See this one, SHA 256. This is the actually token which is decoded, encoded token useful to join the control plane by from the worker nodes actually. So node bootstrap token, these are the node bootstrap tokens and all. So this is all about the kubeadm, what it's going to do at the time of initiating. So this is the visual effect. What is kube init will do? Pre-flight checks, registry checking, TLS certificates generation. So it is kept in the all the TLS files in the PKI etc Kubernetes. These are the most important at the time of certifications. The guys definitely will ask, and you have to investigate in this procedure actually. So they will give you practical hands-on mission. They will ask, they will change some of the manifest changes, and they will ask you do something here and there. These are the things which they can ask. Then kubelet manifest file. Kubelet will interact with the manifest file, HCD, controller, scheduler, API server. These are the control plane components. And then deploy DNS and proxy, generate bootstrap token. This is the way the installation will going to be take care of the kubeadm init. Just post me if you have any doubts on the description. Thank you.